Thank you all for coming. I want to start early, and I know there'll be people coming in and out like that, but I wanted to start early just to kind of give a head start on this. And a big part of this and why I'm doing this kind of workshop is I wanted to make sure I could give people lots of time to answer questions around this. Like RAG has been around for a while. There's a lot of different kind of media attention on this. So having a workshop gives us time to kind of dig into it, make sure everyone's happy, right? You took the time to do this. Right? Otherwise, you could watch one of my YouTube videos and watch it there. But since you're here, I want to be able to answer questions. So we're going to take a lot of questions as we go through this. Some things I'll cover in the material. Some of them might be a little bit too far out. I'll try to guide that. But I'm also here for the next 2 days. So feel free to kind of grab me and corner me with a question as well if I don't kind of not able to hit it today like that. So I'm Raj. I've been in this GenAI space for a number of years. 2 years ago, I was here. I think there was a few people that remember me here. We talked about evaluation in this room. And today, we're gonna go into kind of RAG. I've been doing kind of RAG for a long time. I spent time at Hugging Face, the open source, where we had the developers of the original RAG papers working there. And so I used to go to those researchers all the time because I had customers that wanted to build RAG solutions. So years ago, I was working on this. Nowadays, I work at Contextual AI, which has a platform for doing RAG. I'm not going to talk about that today. I'm not going to do that piece. You can go to the website and learn more. Really, though, what I want to do is just give you a deep dive into a lot of the technical trade-offs and thinking that you have to do around kind of RAG systems and as we move into kind of agentic search and RAG. Everybody on the same page like this? So we've got a lot of good stuff to cover. And kind of the starting point for kind of RAG and all of this kind of comes back to the ChatGPT moment we had a couple years ago where everybody was amazed. Now I have this like chat interface. I can go and ask questions. And then if you show this at your company, right, like some executive goes in and they type in their name and we'd be like, hey, you know, tell me who the CEO is. And this has actually happened, right? The ChatGPT or whatever kind of solution like that you roll doesn't come back with the right answer, right? Like it's been trained on historic data. It doesn't know who the most recent CEO is. And so this is where all of a sudden we realize that kind of the GPT we made really quickly isn't good enough. And hopefully at this point, we all kind of have a sense of what RAG or Retrieval-Augmented Generation is, which in the earliest form was just like, hey, we're going to grab all of our important information. We'll stick it into a vector database, use some semantic similarity to search for it. So that was kind of at the simplest piece like that. And I think many people, it's a 101 project nowadays is to build a simple kind of RAG demo, right? The code looks something like this, where you go out and grab your relevant documents that you want, you break them documents up into little chunks, and then use like a neural network, an embedding model to be able to see kind of what are the relevant chunks for my query here and return those. Has everybody got that? Like basics of RAG are good like that. And I think we've all been here. It's a very easy demo to go out and build. But I think one of the things we get into is, and I see this all the time at enterprises, is yeah, you can build that demo, but as you move it into a production scale inside of an enterprise, there's a lot of reasons why that same RAG demo doesn't scale up very well. And it could be around accuracy. You tested it with a few queries off the top of your head with this, but then when you go and have your actual customers, the users inside the company use it, they're asking very different questions. And all of a sudden, what you thought was a very highly accurate RAG isn't accurate at all. It could be the latency. Maybe you built this which has a ton of extra calls inside there. And so now it takes like 45 seconds to be able to answer a question when your users want 3 or 4 seconds. It could be you didn't really know much about how to scale this thing up for production. And so you went from 100 documents to 10,000 documents and scaling all the infrastructure, scaling the ML that you need on the back end to do all of the documents. It's like, yeah. Could be, and we're hearing a lot more about that, the cost, right? Like, hey, wait a minute, how many calls are you making for this to be able to do this. And then the last thing that we often kind of miss is compliance. Right? Not every document in a company can be read by everybody. So when you build your RAG solution, you need to think about entitlements. You need to think about how are you going to do permissioning around that. So these are the complexities that we often kind of don't hit when we kind of go and build out our own. Now, many of these, we start seeing this stuff like this, and we're like, oh, well, you know, maybe I just need to go read another research paper. Right? Maybe I haven't done enough research, and if you go out there and you look, there are literally hundreds, not hundreds, but there's probably 100 different types of flavors of RAG. It can get really confusing. Like I grabbed this printout of all the different types of RAG, right? And if you're somebody that's building this, trying to improve your demo RAG, right? Like chasing down all these different variations is a ton of different work like that. And often what you end up is like just this crazy kind of RAG system that you build internally that has some of these things, right? I'll grab a knowledge base for some of this, I'll do some agentic stuff, and it's just a crazy mess of stuff that people have kind of for their RAG solutions. So part of what I want to do today is just give you a nice framework that you can kind of start with if you're thinking about RAG. Now, first of all, I want people to think about RAG as a system. To do effective RAG, you need much more than just kind of one embedding model and one generator model. There's a whole system you need to do to think about how am I going to take all my documents that I have and effectively chunk them down. Right? We saw today, like all of these, we saw earlier the quick talk that gave through all the slides, but like all that stuff was money, and we're going to talk about all of that, is you got to figure out how you're going to chunk down your documents, how you're going to do your querying, go in the retrieval piece, the generation. Like all of these are different pieces like this. And we'll spend time, I'm happy to talk through any of the pieces here today, but often, especially as technical people, we want to jump immediately to this and what are the boxes here, which are the ones I should have, shouldn't I have in the RAG system. I think one of the things I like to do is when we have to deal, when we're working on these RAG use cases, we need to first step back and understand a little bit about what is the use case that this RAG is going to be for. Because in building any type of system, you're going to have trade-offs. And the typical trade-offs you have when you're working and building a RAG system around latency, right? How long people are going to wait. Or people want 3 seconds, or they happily 30 seconds. What's the cost of this? And then usually like in something like this, you usually see accuracy, but I'm going to put problem complexity. And we'll walk through kind of exactly what I mean by problem complexity. The other thing that's missing, and the evaluation folks probably remember this from 2 years ago, is when we're working with generative AI, I think another very important consideration when we're identifying use cases is what is the cost of a mistake? If you're doing a RAG use case for healthcare where a doctor's looking it up and if they misses or hallucinates, it's going to be a huge cost, right? Versus I'm just building a RAG for HR so people can see their vacation time, right? The cost of a mistake is very different like that. And that's something you need to consider as you're building this and figuring out the capabilities. Now, I often kind of work with like salespeople that have to go out and kind of scope out RAG use cases. So I often give them something like this, which has a bunch of the list of considerations. This 2x2 matrix I just made with ChatGPT about a year ago. But the idea is just framing in your head as you're sitting and talking with those users who are going to be. Is this a RAG where you're going to be at the top left where it's just simple factual question and answers over maybe a single fact? Or, right, are people wanting this crazy agentic system that goes across multiple documents, that learns something from one question, that feeds it into the next question, that feeds it into the next question? And understanding this is like very important in designing and thinking about like what type of RAG system you want to build. So I'll give you a simple example of this is like understanding like the types of queries that people are going to use. So at the basics, you might have something like, I'm just going to use this very simple extraction. Like, what is Telsis total revenue. But like, depending on your customers, maybe they're going to say instead of total revenue, they're going to say like, how much bank did Tesla make? Something that where you need to understand some type of semantic variation in your queries. Or maybe it's some type of multi-hop where you need you got to go solve one part of the problem, then you have to solve the second part of the problem to get to the final answer. Or maybe the problem is in multiple documents. So your system has to pull information from multiple documents. Or what I often find, and this is where you really have to sit with those end users, is they often have a lot of knowledge that's inside their head or sitting in other places that they expect your RAG system to know, right? Like they just think it's going to be magic when you wire it up to their documents, but you're like, wait a minute, like you're asking me in this question about a law that isn't in any of my documents. I need to go and add that piece to the corpus if I really want to be able to answer questions on this, right? Or, right, like nowadays the flavor is much more of this agentic where I'm taking the place of an analyst and I want to do all of this planning and I want to do an evaluation, which is going to take multiple steps to do. Like having a sense of all of this stuff is important before you jump into this. Now, for today, I want to focus on the retrieval part first as we go through this. We'll come around and we'll hit all the rest if we want. And the reason I wanted to focus on retrieval is because I think it's an area where I see a lot of confusion among folks. There's a lot of stuff out there about how to do proper retrieval. Right? Like retrieval involves lots of models, right? Like neural network models. It can get very confusing in terms of what to do. There's a ton of vendors that have different solutions for retrieval. So I want to start by kind of taking apart retrieval, making sure we understand the best way to kind of pull stuff out. All right, I've talked a bunch. Let me pause here, see if there's questions. Is everyone with me on this workflow so far like this? Okay. All right. How many people here have built RAG systems? Let's get a sense of, okay, a lot of people have built RAG systems like that. Okay, good. So yeah, keep me honest as we go through this. Oh, go ahead. Yeah. Mm-hmm. Yeah. Yeah. So I'll come back at the end. We'll talk about parsing like that. But yes, I mean, figuring out how to break up your documents affects your retrieval piece like that. And so yes, there are many chunking strategies. I don't have a definitive answer on which one like that. I can give you some trade-offs like that. Okay, good. So let's talk about how we retrieve information. Right? This is fundamentally a big part of kind of any type of system is we have a lot of documents. The documents have probably been chunked in some place because we need to chunk documents after all because lots of documents in enterprises are 500 pages or 1,000 pages. As much as we have these lovely long context LLMs, you can't assume that you're going to be able to take all the documents that you have inside your company and put them inside an LLM. Even if, right, like Magic World, if you had like 100 million context-linked LLM, like how efficient would it be to take all of your content and put it inside of a model and run a query against it every time somebody had a question? Right? Like this is why we basically break this up. It's just much more efficient to take our knowledge, break it up into smaller pieces for search. Okay. Now, I want to talk about 3 different approaches today that are important. BM25. We'll spend some time on language models. We'll probably spend most of the time there. And then at the end, we'll talk about doing agentic search, right? Using the latest LLMs for that. So this is how I broke it up into these 3 big categories like that, because I think they're all important and we need to think about them when we're building our RAG solutions. And in terms of if some of you think in code, right, you can think of it as when we're building that, yes, we get the chunks, but the next step is after we get the chunks, we need to do this retrieval, we need to do this matching part like that. So BM25, does anybody know what it stands for? Many of you have probably said it. Best match is the BM. Any idea why it's 25? The seed where it started from? It could be. In this case, it took them 25 attempts before they were happy with the finished algorithm in terms of the hyperparameter. So this was the 25th version. So, and many of you that are working away, just be aware. It might take the 25th version before you get published out. So the BM25 works by taking all the words that we have in our documents and creating this inverted index. So it takes all the words that I have, and then I just link it to what document it is. So in this case, for example, if I go and I'm looking for the word butterfly, I can go look at this index and be able to see that, oh, butterfly is in document 1. Make sense? Like, this isn't any kind of thing fancy. It's just like, let's go through this and do that. And so that's the basic essence of kind of what BM25 does, is it kind of helps us match those words that we have. Now here's some benchmarks kind of for running this, and like I just used, this is again like the world we live in, like this, I just used ChatGPT to help me build some benchmarks to kind of show you guys a visualization. Like any of you can play around with this and have the code for this. So what this does is, like, you see the number of documents there. So linear is just if I did a simple find search, right? If I did just like control find and I just go right down the list and I do a search like that, right? A very basic search. And you can see, right? The find search, as you get more and more documents, right? Like it takes much, much longer to do like that. Like, yes, if you have a small amount of documents, you could do a simple search like that. But on the other hand, you can see like BM25, just how much quicker it is than that control find. Now, there's an upfront cost. You have to build that index. But once you've built that index, you can just quickly consult that and find the right document instead of like computationally going through it for every query. Everyone with me so far on this? Right. Okay. But like everything, right, there's trade-offs of this. In this case, you've created this index that has these specific words. So if you have a query that, for example, has the word physician, but your documents all use the word doctor, what's going to happen? Right? It's not going to find it, right? Like it has to have that exact word, right? Because you've built that inverted index. Or if you have IBM, right? The other example is, right? In one, somebody typed in international business machines, but your documents all use the abbreviation IBM, it's going to mismatch. It's not going to be able to find that piece. So that's the downside of kind of using this type of approach. Now this is where it comes back to like knowing your audience and the people you have. It's a strong baseline, pretty much for any type of document search where you have real humans kind of doing the search that understand their material. Like it's a very quick, easy baseline that you should always implement. And if you have people that know the information, right? They know the exact keyword that they want, it works really well. And this is why it's a strong baseline for a lot of systems, and it's probably the most widely implemented way that we search like this. If you want to try it yourself, there is an implementation in Python of BM25, so you can go around and kind of play around with it or implement it across your own documents as well. I'll stop here. Anybody have any questions or experience using BM25 that they want to share? Was everybody like, was BM25 something that we're all pretty comfortable with before, or is this new? Good. Yeah, sometimes you'll hear the word sparse search with this, yes. I tried to keep it plain English, but yes. Yeah. Again, like this is like the easiest first thing to implement. In fact, if you look at like a lot of the, some of the papers we'll talk about the neural network models, you'll see that a bunch of times that this baseline beats them in lots of use cases like this. All right, so let's move on. Let's talk about language models here. Idea is now I have my text. I'm going to do an encoding and convert that text into a numerical representation. Language models have been trained on lots of this material, so what they learn is now similar concepts go together, right? So this is kind of basic. So you can see now in my upper left corner, for example, doctor and physician are close to each other in this semantic space, or IBM and International Business Machines are close together in the semantic space. So now these relative concepts I can find like that. Right, we know this, right? I've been talking about this for years, right? Like Google Search rolled this out a few years ago, and it was like the biggest thing they had to improve their search experience. If you go out on Hugging Face and you go and look at these models, you'll see they're widely used like that. There's tens of millions of downloads around this idea of doing this. But for all of us, right, like to think practically, like, okay, like I get that I need this language model and the semantic search is good, but which one should I use, right? Like guide us a little bit on this. So if we look at this chart, you'll see the left scale here is NCDG, which is a metric for retrieval quality, on nanobeer. And nanobeer is a small subset of BEIR, which is BE stands for benchmarking, the IR stands for information retrieval. So it's a widely used benchmark for judging how well these models can retrieve. The bottom x-axis there is how many sentences per second you can process. So you can see some of these are much quicker. You can see BM25 down there. It can process a lot of sentences. It's way on the right, while you'll see some of these other models are way on the left, like that. All right, everyone with me so far? Kind of oriented yourself, right? These are two of the trade-offs we think about all the time. Like, how good am I going to retrieve it? How fast is it? Okay. Now, you'll see like there's some models here on the right that are even faster than BM25. And so these are what I call like the static embedding models. And for anybody who's been in this around for a while, we had models like word2vec, for example, that take a single word and find an embedding with it. There's that relationship, one-to-one relationship between a word and the embedding. And this is what I call uncontextualized. I'll show you what contextualized means in a minute. Now, there's an accuracy drop-off, which is why they were right lower down on the piece like that, but they run super fast, lightning fast. You can run this on a CPU if you want to do a search like that. And these static embedding models we've had for a long time. And if anybody is newer to this, this is where, for example, you can see all those crazy maps. Right? You can get the word2vec maps and see all the different words and how they relate to each other like that. So this is like that concept you've seen a bunch of times like that. Like I make these videos, the embedding models always get a ton of hits like that. So that's great, but the problem with, of course, those uncontextualized ones, and this is the trade-off, like sometimes words have multiple meanings. They just don't always have one meaning. And so knowing the context of the sentence, so what is my context here? Like the model was shooting in Paris, understanding the full sentence gives it a very much different meaning like that. And so this is where kind of contextualization comes into play when we think about this. Okay, everyone with me? Okay. So now we need models that can kind of understand all of these pieces. And that's where all those other models that we have here in this chart take into account those places like that. Now, I don't have time to go through all these models at once, so what I want to refer people to is what is called the multi-text embedding leaderboard. How many people have seen this before? Maybe a few, but not that many. Okay, so I went ahead and went to the leaderboard. If you type in like MTEB, you'll be able to see it yourself. So what this is it's a leaderboard. It's out there on Hugging Face. It has all the popular embedding models. In this case, there's something on the order of about 300 different embedding models on here. We'll get basic information about kind of the size, how many tokens they can take. But the valuable stuff is all the stuff over here in the green. What people have done is taken those different embedding models, run them through different types of tasks and data sets, and given us a very public leaderboard to see how all these models do. So it's an easy way, as you're thinking about your task, which might be a little bit unique, to think about what would be a good embedding model to be able to go out and use this. And you'll see there's hundreds of different models here. There's different domain-specific ways you can search, language-specific, right? Language is a big difference where embedding models might be different like that. So this is kind of an easy place to start looking at and understanding different models. Now, as you do, there's like lots of cool pieces here. So for example, here you can see this chart has the number of parameters by the, sorry, I'm trying to, by the performance. I was trying to show you that axis. Why can't I show you that? This is where these spaces, oh no, the Wi-Fi is going to be too slow. Okay, there we go. Let's go. Performance by model size. There we go. Okay, there we go. So now you can see on this plot here shows all the models, but it gives you the overall performance on the tasks by the number of parameters. Now, I think one thing that's interesting is look at this. Why is it over here? Why do we have models down here that all have the same amount of parameters but do differently on tasks? Why is that? Why is NV-embed down here? What's up at the top? And Qwen3 embedding at the top, right? In the same number of parameters, but one of these is a lot better than the others. Why would that happen? Same size, right? Like it's the same amount of things. It could be like, yeah, some of it's a little bit different architecture and philosophy. Yeah. So in this case, what's happened, like Qwen3 is like the latest, greatest embedding model that probably came out a couple weeks ago. And so some of these, as we've gone through the years, we've learned a little bit about getting higher quality training data, figuring out what type of architectures work the best. So there is some type of advancement that's happening with these embedding models. It's not changing overnight like that, but this is where one thing like going and looking at the graph helps you understand kind of where the models are and what might be improving like that. Recently, in just the last 2 weeks, there's a group that has started this new one here, this retrieval embedding reader board, the RTEB. Now, this one doesn't have as many models on it yet, but one of the nice things about this leaderboard is it has, over here you'll see mean private. It has a private leaderboard. So that means the people who build all these embedding models don't have access to the data that we're testing it on. There's a private held out set that only people that, when you run it on the leaderboard, see that. So it gives us a little bit more kind of feeling that maybe they didn't just try to overfit to the training data to game their way to the top of the leaderboard, which is one of the big problems with these leaderboards like that. So we'll see how this kind of RTB grows and the kind of the usage like that. But it's a good signal for those of us who want something like that, a little fair measurement of the quality of the models. Go ahead. It's just a little bit of progress like that. And you can literally like see it, like you can go and compare different generations of models and see what it is. But the performance is like, yeah, 1 or 2 percentage points. Like, I don't know if it could matter a lot for your use case, it could not. But it's nothing that like is at the pace of like, for example, what's going on with LLMs and the difference between 3, 5, and 4 and like that. So, yeah. Yeah, I'm going to repeat the question because they're doing the audio and I don't know if it'll show up on in the video recording. But just noticing that the Qwen3 models, right, because they're built in China, they don't have access to GPUs, so they've had to be a little bit better with dealing with the resources and the efficiencies there, and so it could be better like that. So yeah. 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 Yeah, so the question is yeah, why don't we have a continuous spectrum here, and why do we have these discrete categories? And it's largely because of very traditional practices in how people develop models And it's largely based around wanting to compare models to. Because when you're in a lab and you're building a new model, you want to see how your model compares to other models. And so if you're all on the same size, the same number of parameters, it gives you a fair way to do that. So that's why like the 7B area, you see lots of models there. But you don't see like 5Bs or like 9Bs, right? And it's just simply because the developers gives them a good benchmark to make sure that when they're training their model, that it's actually getting better. Because if they trained it in 5B, you wouldn't know if it's better than a previous generation model like that. So it's more convention than necessity. If you're building your own, you could. Now there are some, like if you want to fully use GPUs, you want to maximize bits, there's some of that, but yes, most of it's just convention. Yeah. All right. So and when you're picking these models and you're going through this, of course, I showed you the data on the performance there, but if you're putting these into your own systems, your own infrastructures, there's other considerations. Right? Like how big of a model you want. Some of these are like basically large language models that take 8 billion parameters or even larger. And so then you need big GPUs to run that kind of stuff. You want a smaller one that you can run on a CPU. Maybe you can grab an open source model and maybe you want to quantize it to try to eke out a little bit more speed. So these are like the considerations that you want to make. There's also, when you look at these models, when you're picking out the embedding models, is some of them have different training data that they have. So especially for multilingual needs that you might have, right? There could be domain-specific embedding models. For example, healthcare is a great example of an area where terms are used in a very specific way that an embedding model off the shelf might not work. And so you might want to look for embedding models that are pre-trained on that, or, right, worst case, you can always fine-tune your embedding models as well, like that. All right. Are we good so far on this? Okay. I think one of the interesting developments that's happened recently when we have embedding models is typically they give us we pass the text in, we get out kind of an output of an embedding of fixed dimensions. And so most of the models have very fixed dimensions. One of the recent developments has been these Matryoshka, I can't say it, Matryoshka? Matryoshka? Yeah. I didn't know if it was Russian or Japanese. I had no idea. It's Russian, okay. So with these embedding models, what you can do is at time of inference, you can select how big of a dimension you want to receive. So some things you might want the full quality, all of it, but sometimes maybe I just want to have a smaller amount because I want to save space for storing this. Maybe I want the compute will be a little bit faster. And these models have been trained so as you kind of shrink down that and make that embedding smaller, that the quality of your embedding that you have will still be high as well. And so it's an interesting development. We've seen a lot of recent embedding models nowadays be trained in this way. So if you use, for example, OpenAI now kind of supports this technique inside their embeddings that you get with the API as well. Now, when we talk about the embedding models, I think the biggest thing is to recognize there's an entire set of embedding models that fall under sentence transformers. These are very important for retrieval and RAG because most of the time we're working with documents that are written in sentences. So a model that's optimized for sentences is going to do much better, which is why pretty much all the RAG models that you see out there for embeddings all use this type of sentence approach as well. Another one that you'll run across are what's called the cross encoders, also used as a re-ranker commonly. And so what these models do is they don't just encode the text that you pass it, they also look at the query that comes in, cross it with the information you bring in, and give you a score. Now these models typically use a little bit larger language model, and what they're really good for doing is figuring out that relationship between that question that's being asked and the document, and that gives you a little higher quality answer. And so that's why you can see here is they're often used in a second stage after you get all your embeddings from a very cheap, fast embedding model that gets, hey, these are things that are in the ballpark. The re-ranker, you can think of it as like a fine-tuning. It looks at all the things that comes back and then tries to improve it by giving a score to each one of the chunks that comes back based on the query to see what works the best. And you'll often see in many RAG implementations, you'll see a re-ranker used as a way to improve the performance because it's an easy, well, not an easy way, but it's a well-known way that you can get a couple percentage points improvement on your retrieval by having this extra step. Now the downside, of course, is like this extra step is going to cause you latency. So this is where it comes back to what your requirements are. Now you can get re-rankers of different sizes. Some are smaller, some are faster in terms of quality like that. Now as we see this world of like language models being used for these encoding tasks, one of the things that's happened is models like re-rankers nowadays are, oh, this is the hands, sorry, this is a hands-on. So I have a bunch of these hands-on slides, but if you want to play around with the code and see what the effect of a retriever and a re-ranker is, that's what this Colab notebook does like that. It's around for many years like this. But as these re-rankers become language models, we can start to prompt them. So this is, I work at Contextual. We released a re-ranker where you could give it instructions. It's open source. You can go grab it like that. But it gives you another additional strategy for thinking about how to improve your re-ranking by adding in this. Now, like I talked about all these retrievers we have and all these different strategies, and you can overlap and use these strategies together. So here's kind of a simple, on the FreshStack data set, you can see here by kind of using, I don't know, pick the E5 Mistral with, okay, if you use the BM25 and if you use the BM25 with a re-ranker, you can see the improvement. If you use the re-ranker with the model, you can see an improvement. If you take all these different approaches together and use them, the far right, you'll get the best kind of improvement like that. Why wouldn't you want to do that every time? Why wouldn't you just use all the retrievers in your pipeline? Cost, latency, right? Like it's a ton of extra compute you're putting to do it. So this is where, again, like you have your trade-offs. Like if you want to throw like everything at it, you can use multiple retrievers to do it. There's nothing wrong with a technique that has you do that. Right. So there was a Kaggle competition where they used cascading re-rankers as part of this, where they had one re-ranker, right, get fed in the top 64 that brought it down to the top 8, then brought it down to the top 5, and then ranked the top 5. Like they used a ton of different models, right? Like Kaggle is fine. You can use all the compute you want in these competitions because you're really trying to optimize for really that high accuracy like that. So this is where like you can go crazy by putting together lots of this stuff as well yourself. But this is where I'm like, an easy baseline that's pretty widely recognized here is just start with a hybrid search, the lexical semantic, right? A very basic piece. Lots of databases, as we'll talk about, kind of support this nowadays. Pass it into a re-ranker if you need that little bit of accuracy. It's an easy thing to set up, and it's a good, strong baseline for then figuring out how to improve this like that. Okay. Let me pause, or I'll put up this next slide here. Let me pause, and this is a good time for questions before I keep pushing on with this. Oh, go ahead. Yep, and back. So the question is, why use this reciprocal rank fusion? Well, what's going to happen is when you do BM25, you're going to get a list of search results from BM25 for what's the best there, and then your semantic search is going to give you a list of what's best. And the reciprocal rank fusion just takes those two lists and converts it into one, is what it's doing. Because otherwise, you're going to have two sets of lists and that you're going to have to pass. Now, you could just say, I'm going to take the top 10 from semantic and the top lexical, just put them all in there, like that. So it's a union, but the idea of that is it's a little bit of an algorithm. So it's not just taking all of them, it's ranking them to see what is the strongest contenders. And so if you type it in, you'll see it's quite widely kind of an easy algorithm like that that's used to identify kind of what's the best way to kind of take the two lists and combine them. It's really fast because it's just combining two lists like that. So it doesn't take very long. Yeah. So the question was, yeah, what is the use of this matryoshka embedding models? I haven't seen a lot of the use of it in practice. It's a very kind of appealing, kind of sexy thing that makes a lot of blog posts and a lot of interest. Like, oh, you can change the numbers here and done that. I haven't seen like a huge convincing case for people that have really kind of used them to the the effect like that. So I think the biggest thing I see with the embedding models that people do is like quantization, that sort of thing, to be able to kind of get speed out of their embedding models is mostly what I see. Go ahead. Yeah. Yeah. Okay. I have this summary slide. I'm not going to go through it here of like just taking the trade-offs of all these approaches, but hopefully you've got a sense now of like the different types of kind of neural network models we can use in this way. All right. Now, the research, as we mentioned, keeps going on. Just like in the last few weeks, there was a BERT came out of Johns Hopkins, right? IBM, Google kind of released embedding models. And this is where we talked about the rate of the progress. They're eking out a little bit better performance. Like if you're starting from scratch, sure, go grab one of the newer ones. But if you look, lots of people are still using embedding models that were trained like on data from 5 or 6 years ago that haven't even seen the word COVID, and they're quite widely used like that. So there's still a lot of validity and a lot of value out of those older models as well. Now, what we focused on here is retrieval of, I have a lot of chunks and I need to find the most relevant ones. There's a lot of other methods that you can use for this. So we talked about sparse approaches, for example. You can use techniques like splayed, where I'm going to stick in a bunch of semantically related words into my lexical search to make that go faster. There's other techniques you'll see like Colbert, which comes from like Late Night at Colbert, the talk show, late interaction, where we're going to take all of our documents and we're not just going to break them into chunks and get embeddings for the chunks, but we're going to get tokens for every word in the document and compare all of that. Like, it's a lot more tokens, right? The vector stores love it. But it's another strategy you can use. Graph RAG knowledge graphs, I'm sure many of you have run across that. It's another equally valid way of doing retrieval. You're just spending a lot of time up front taking your data, creating the entities, the relationships, structuring all of that data like that. So this is, again, like, if your use case supports spending that upfront time to do that, I usually recommend to people to spend time doing metadata. As soon as you get to large data volumes, having metadata is a very important way, so you're not searching 1 million documents with every query, but every query can be narrowed down to a much smaller scope to do that. You don't need to necessarily go to a knowledge graph, just having good metadata can do that. But this is where, like, understanding, you starting with a good baseline, looking at your problem, and then figuring out, like, is this an effective strategy is kind of what I recommend. Like that. Is there any, like, RAG flavor of the month that people want to talk about or ask about before I move on from there? I mean, sure, many of you have seen like knowledge graphs, right? Like that's been a big thing like that, but right, the funny thing is like very few people actually implement them without, especially cheaply. Okay. A few operational concerns to think about when you're doing this, like when you're working with embeddings, for example, you have to do calculations to figure out what is the similarity, right? There's different libraries for that. Face is a well-known one that's kind of been optimized for computing embeddings like that. Another operational concern is like, I have embeddings, what am I going to do with them? You don't always have to use a vector database. Like if your type of project that you're working on doesn't have a ton of vectors like that, you can just store them in memory. Oh, everything okay? You can just store them. you can just store them in memory, and it's super quick. And so this is often like an easy thing, and you can avoid the whole vector database and get very fast speeds like that, depending on what you do. If you want to go into vector databases, I'm not going to go deep into them. Here's an article that was on kind of S3 vectors, but goes over a bunch of the vector databases like that. A big part of it is just thinking about what you're looking for in terms of governance, as well as speed when you start thinking about the different approaches. There's a lot of vector databases and vendors out there in this area like this. And as I mentioned, like metadata, like as you get more and more data that you're using and for retrieval, your retrieval performance, like when you're using these types of neural network models, is going to go down. It's going to be harder and harder to differentiate this as you get larger and larger tokens. So this is, in this graph, you'll see, for example, the lexical retrieval keeps working fine as you get bigger and bigger, but the cross encoders doesn't do nearly as well like that. Okay, so I'm going to move on to agentic RAG here, but let me take a second here, make sure there's no cross encoders, encoding, retrieval, embedding models like that. Yes. Mm-hmm. Yeah, and so it's just the CPUs have just been for ease of like that. But yes, you can run all of these things on GPUs. And the thing is often with the way embeddings are, you can kind of parallelize out the tasks. So you can just have lots of GPUs available for those tasks. And then depending on the model you have, you don't necessarily need like an H100 GPU to be able to run the embedding model. You can use smaller GPUs as well, and then just distribute the task like that. Works really well. So yeah. And then techniques like quantization, like that work as well to speed it up. Okay. Usually when we talk about RAG, the time as we spent doing the embedding is very, very small. Like re-ranking is a much bigger piece if you're using that. Yes, go ahead. Yeah, I haven't talked about that. So if you're using lexical search, it's going to have to know that that new document is there. Similarly, if you're using semantic search with embeddings, right? As any new document comes in, you have to build out the embeddings for that. So that's part of your ingestion pipeline, is you have to create that stuff every time. Mm-hmm. It sounds like a real problem of like building this index for BM25. I've never known anybody where it's a problem. I think almost all the databases that you have it already built in for that piece like that. So like I get it from like the theoretical perspective, but I think from a practical perspective, it's very solved and it's very quick like that. Yeah. Yeah. So, I mean, the question really is, let me see if I can answer this right, is a little bit around entitlements. Like I have all these documents and I have considerations where I don't want to make sure people have access to everything. So what my suggestion is you have permissions for your documents. you have permissions for your documents, like each person has access to it. So you can either, before the retrieval part, filter out the documents that people don't have access to, so you can only search on the documents that you have access to. Then when we get to the generation side as well, is another place where you can add the entitlements, where the documents that are being fed in for your writing your final response, you run your filter then and exclude any documents that people don't have permissions to. So there's a couple of different points that you can kind of implement that piece like that. Yeah. Mm-hmm. Yeah, well, and usually for indexing, you're going to index them all, the documents. It's just like at retrieval time, you'll filter those out before you're even passing them down in, or you'll just filter it out at the other end like that. So, yeah. And it's a really important enterprise consideration. That's why I took the time, because most of the books don't tell you about that piece, but if you're putting this inside a company, you have to think about that. Okay. All right. Okay. Oh, did I lose my full screen? Here we go. All right. So I'm going to move to kind of agentic RAG, and then we'll come back to like chunking questions as well. So traditional RAG, I think of it as like one shot. Somebody has a query, you go, you retrieve back the documents. What we're going to see with agentic RAG is we're going to be able to do multiple queries to be able to answer these questions better. And the reason we can do all of this is because, and we've seen it just literally in the last year, we now have these large language models that are much better at using tools and much better at reasoning through using tools. So this is like Agno is an open source one, right? They have lots of examples of building reasoning agents, kind of using capable of reasoning agents. And the simple idea is now when I have a query, I just don't get an answer, but I have a loop back that asks, hey, did I properly answer the question? If the question isn't properly answered, let's go back and think about how to improve that piece there. And what it ends up looking like in practice is something like this, where you'll see different reasoning steps that are made by the language model, and that links you to different tool calls. So it's going and looking and trying different types of queries as it tries to figure out where the gaps are in the information. And then it uses all of that to write your final response. So it's kind of a multi-step approach to doing that. Everyone with me? Okay, so far? Now, there's a bunch of these out there. So LangChain, for example, has their Open Deep Research, which is an example of using this agentic approach to do research tasks that are open-ended. And they have, for example, you pass the task over, they take the task, they break it into multiple parts. They have different sub-agents that go work on those parts and then come back to the main one and do it. So this is a very common kind of architecture scheme that we see kind of using multi-agents or sub-agents to do this. They have their repo is open. You can go look at the prompts, steal it for yourself for work as well. There's also a benchmark around this deep research, which has 100-level PhD tasks around it. So you can see how well you kind of compete against each other. The thing is as you get into these research things, they can get very expensive very quickly, where you can spend easily $1 a query because you're running through so many tokens, doing all of these calls and all of the reasoning like that. It's been productionalized. So many companies, Westlaw I saw has kind of a deep research thing. I see lots of people inside of enterprises building their own deep research tools. It's a pretty easy thing to kind of build out nowadays. Now, one benchmark I like using, it's a public benchmark, is Bright when we're thinking about these types of reasoning tasks that are a little bit more difficult. And if you look at the benchmark here, you'll see that we have things we talked about earlier, like simple extraction, simple keyword matching. But some types of queries take a little bit more thinking to do. And we see this often when you look at users who are trying to use these systems, where it's not just finding one piece of information. I have to kind of think through a little bit to be able to get it. So the Bright benchmark is out there. One of the things is they have a leaderboard. So if we look at the top model right now on this bright leaderboard, you'll see it's using a lot of the techniques that we've already talked about. The first couple models, I looked at them just this last week, and they use the same kinds of approaches that we talked about, where you chunk out documents, you use a retriever, you use a re-ranker to get the result back. And it's using that same kind of RAG approach, but now what you're doing is you're giving it a query saying, go out and do some work, reflect upon it, rethink about your queries, do some more work like that. And this is a kind of an effective way to handle much more complex tasks. Now, I've seen this, like seen this with things like kind of self-RAG, which uses that same approach of like, we do the initial RAG, we think about the results, can we improve upon it? And so this was a Reddit post that somebody talked about how they kind of set up their own RAG to do this. But of course, one of the things is you can set this up and you can run this, but it can also be super inefficient. You can end up doing lots and lots of tool calls and reasonings and getting to the same point that you would have if you just had a simple kind of RAG piece. So this is one thing to watch out with some of this agentic RAG, is it looks cool, but it's an easy way to burn a ton of tokens for that and take a long time. So if your users don't want to wait 45 seconds, right? Like, this is not a good solution like that. Now, the great thing about this, though, is it can work really well. So Wix QA is a public data set. It's a technical support. It's from the company Wix out there. So I grabbed this data set. These are numbers I ran myself, where I used the one-shot RAG. This is the baseline that's in the paper. Got something like 0.76 on their factuity benchmark. But then I hooked it up with agentic RAG. Hooked it up with GPT-5 and being able to do multiple tool calls. And you can see I was able to get right away to 93%. Like, I didn't do any like fine-tuning of the prompt or anything like that. I was able to get much better performance. But like, it takes 50 seconds for a query. So this is where you can have those trade-offs that you'll have to think about as you set these systems up. I just let the LM decide when to stop. Like, I had a maximum number of turns, so it wouldn't go on forever like that. But I let the LM kind of, when it was in the prompt, kind of when it felt confident about its decision, to then stop. Mm-hmm. Yeah, so the question is can you get stuck in like a loop of, you have a bad tool call and the LM keeps calling the tool loop over and over again? And those are really considerations, and this is where like doing your testing and your evaluation is important on the front end. Most of the times you can set an upper bound where you tell the LM like, don't do so many calls, or you can literally, if you're using a graph-based system, set that in the graph that you use to kind of limit the tool calls like that. But yes, if you have bad tools, that's going to screw up the system like that. But you could see it in your case where maybe you set up your agentic system and you wanted to call the SQL database for some query, but it doesn't have access to the SQL database, so the tool call fails for that particular individual, but works for other people like that. So yes, there's lots of nuances that you can get into with these systems and rights and permissions. Yeah, so the question is how was I evaluating these on helpfulness or relevancy like that? So for this particular examples that I'm showing you, they had their own, in the paper, they had this factuity benchmark that was an LLM judge, where it says, was this like a factual basis? Was the answer like based in the facts of that? So that's what it used like that. But you could use other metrics as well. So it has access to the, yeah, so it has access to the gold answer, and it has answers to the response. And so it just sees, was the response kind of covering the same factual information as that, was what that is. So yeah. So yeah, if you look up Wix QA, like they shared their prompts, their paper, all that stuff is publicly available like that. Their data set is on Hugging Face. So for both of these, we're using GPT-5. For both of them, I'm not using the intrinsic knowledge in GPT-5. Like the prompt instructions are you use the context that you're given for it, like that. So just the ability, right? I mean, you can see like 15 points or whatever, like just the ability to like look at the answer and be like, I didn't see it right. Let me reword the question is kind of what get that boot, because sometimes, but this is also the really one, I think one of the cool things about the agentic approach here is if you're building these systems, this now gives you like a baseline of what's possible in your system, right? Like why couldn't even the agentic system with multiple queries not find some information? Is there some information that you have that's deeply hidden? Or if you look at the difference between the 0.76 and 0.93, well, the agentic system that did multiple queries found the information. Why don't I go back and look at the examples where it improved, figure out why it improved? Maybe it's feeding information into my current chunks, my current information, so then my single shot can be improved because of that analysis. So I think it opens us up for even a lot of other things, even if we don't actually implement it out like that. Go ahead. I think it would be to probably the final. Well, you're right. Like it might be 5 seconds on the one shot to the first token, and it might be 50 seconds, might be the total time like that. But even then, right, it might have been like 45 seconds to the time to the first token or something like that. And the point is just, I want to just point out that there's a big difference here like that. And like on the agentic side, you could make it much faster. The one shot you can make faster. I just want to give people a ballpark for expectations around this. So in this case, I used GPT-5 for the generator, and for the judge, I used a Claude Sonnet model. So, and in the paper, they might have used slightly different models. This is what I did when I ran it myself. Yeah, I mean, for this type of benchmark where you're comparing the two, you don't need the smartest model to do that kind of thing. And so I think basically, I could probably even have used a smaller, cheaper model and probably had the same. But it's an easy thing to point out again, like as you're working with LM judges, to try a couple and make sure that they align with your humans and that they're working like that. So there's an old saying like, yeah, we want different ones. And I think when I did my evaluation workshop 2 years ago, I said, do not do the same. There's a lot of people that use the same one, and it's not the end of the world like that. Like like there could be like a little bit of bias like that, but I mean, sometimes it's not going to make that big of a difference like that. So, yes. Yeah. So one of the questions was, well, so the so the agentic thing is making a query. It's looking at the results that come back, rewriting a different query, running it results, and coming back like that. Now, the question was why don't you just do like 3 parallel calls where up front, you just do some semantic variations of that and then pull back the thing. I think the agentic would still have a little bit of an advantage generally because it's not always just a semantic variation of your initial query. It could be that based on the response, maybe there's a different part of the problem, a different act, a different type of document that you're like, oh, we don't have information on this. And now I can go and query, hey, can you give me the specifics for the technical support rule 35 that I didn't know at the beginning I was able to do? Yeah. Yeah, and I think, right, like especially if you're focused on like latency and you don't want the multiple things, it might make sense doing multiple calls, pulling all that stuff together, and you might get a better overall response in a much quicker time like that. So yeah, if you try it, let me know. Yeah. Well, and this is again where like the agentic situation might help you figure out like what are the best queries to do in that type of case like that. So the other big thing, the other big insight kind of from the agentic approach came from this Bright paper. And so I want to look carefully at this graph here. And so if we look here under the Quen, this is using the Quen embedding model and the performance. So the NCCG is the retrieval performance. The higher, the better. And what I want you to see is that GPT-4 column there. So you'll see the Quen and how it does when you're using the Quen embedding model with the GPT-4, right? We talked about like what model you're using with this. And you can see like, right, the SBERT model, just simple sentence transformer, doesn't do nearly as well. But look at this model over here. Our old friend BM25 rearing its head, right? Like not even using a neural network. By just using GPT-4, using that simple keyword BM25, was able to get even better performance. And so this is where like a whole new trend is coming about of rethinking. Instead of spending all that time that I did up front creating this embedding model to get the semantic relationships, why not just let my language model, which understands semantic relationships, just handle this on the fly? Oh, go ahead. No, oh, sorry. This is the Bright research paper, so it's using the Bright data set. So this is using a data set that's based around very tough questionings where you need to do multiple queries kind of to do the retrieval piece like that. And so I ran this myself. So I took the Wix QA data set, and then I have my own financial internal data set of like 10 Ks. And so what I did was I just hooked up GPT-5 with BM25. I just removed my embedding model out. I removed my re-ranker out of my thing. And you can see like I get pretty much on par. Like it says I lose a little bit, but just using BM25 with kind of a smart reasoning model like GPT-5 and doing multiple turns works much better. Or the BM25 only works on par. The BM25 was about like maybe like a 10%, like a slightly more overall in terms of the latency, because I think some of the queries might get an extra call or two. But I didn't really optimize it for BM25 or anything. But I mean, this is where you see this trend nowadays of maybe we don't need this embedding model in the middle if we can use these reasoning models. Now, of course, there's the latency hit here for when you're doing this. But the other place that we see this is with code search. Code search has never really worked that well with embedding models that were really based around language. But if you use Claude Code, if you use Cursor, like all of those nowadays are starting to use this idea of I'm just going to use BM25 and grep to search everything and then just use my reasoning model to tell me was the search good and just go back and forth like that. And so this is kind of an emerging kind of the cool trend is just to like use this. Now, if you're in a hurry, if you want a richer answer, right, like using the other pieces that we talked about is going to make a difference like that. Okay, before I talk about this slide, I saw there was a few questions. Yeah, go ahead. Yeah. Yeah, so one technique we haven't talked about, we're hitting here, is like query reformulation, where my initial query comes in like, hey, tell me Tesla's revenue, but I reformat it into, tell me Tesla's revenue minus profits over the word year. And so this query reformulation is a very effective way, especially if your users aren't very good at writing queries, to get much more meaningful queries that do a much better job at retrieval. So you could try this test where you could say, I'm going to run a query reformulation step and see if that helps improve it. I don't know. I mean, query reformulation can give you some bump like that, but this is a pretty big bump in terms of like the performance like that. Mm-hmm. So what I told people at work based on this result, and I think this is going to be like if you're building a modern RAG system, what you should do is some type of LM routing where when that query comes in from your user, you should just have a quick lightweight classifier that decides, is this a simple query that needs one-shot RAG, or is this a more complex query that needs kind of this agentic kind of solution, right? You see this, if you're using GPT-5, you see this all the time. Like, is it a simple query, or do I need thinking turned on and going through that? And there's no reason you can't kind of incorporate that same approach into your RAG systems as well. So yeah, absolutely. That's going to be, as we're building these more complex workflows, that's going to be a thing. Yeah. 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 If anybody can take a picture of me while I'm on stage, I would appreciate that too, and put it on LinkedIn. I need that, like that. So the question was, I want to get recency for documents. How can I do that? There's a couple of different ways we can kind of work in something like recency for that. First is knowing the date of when you're doing it. You can bring it into retrieval. So you could use it as metadata when you're pulling that in and just, for example, limiting yourself to the last week's documents and just filter out those. You can use it in the re-rankers. So this is what we tell people is we use that instruction following re-ranker, and we prioritize the most recent information by using a promptable re-ranker in that way. So those are two ways you can kind of get that information in there. If you're using a reasoning model and you tell it what the current date is, it can then, you got to tell it the date. If you don't tell it the date, it doesn't know. But if you can tell it the date, then it can also, as it's doing its search, look for things that are closer in time as well. Yeah. So that falls under the kind of the other approaches. Like hide has been around for a couple of years, like that, the kind of the hypothetical piece. I've seen like mixed progress. I think like OpenAI's Dev Day like 2 years ago had an example where they showed like they tried hide, but it didn't work in their graph like that. So this is where like I always tell people, build your baseline first, then you can try the different methods depending on kind of where your weak parts are to see if they can improve it like that. So it's not something that I see improving it every time. So that's why I don't kind of put it in the standard approach. Yes. Yeah, so the question is what do you do when you have your RAG gets two documents that are in conflict? And it's not a surprise that they actually will get two documents in conflict because you're looking for relevant information. And you could have, right, a version 1 of a document and version 2 that have different pieces. So one piece is, well, do we want to prevent that problem because we know only the most recent version we should keep? So you can have, this is where like metadata, where that filtering comes in, where we can deprioritize the other ones. The other piece is, this is where your prompt, your generation comes into play too, because you can add more reasoning if you know, for example, that, hey, you should prioritize recent versions in this. You can tell your prompt to help with those kinds of conflicts. But a lot of times we're relying on those reasoning models, and this is where prompting comes in really play to be able to solve those. So that way you can help the reasoning model figure out which is a better decision to make when you have the conflicting documents like that. Yeah. Can you give me like 3 minutes and I'll get to the chunks? Because let me just finish off with this. So as we're talking about these systems, I think one of the things is with retrieval, you have a lot of different methods. You can pair them up with each other. You can use a very simple, so this was DoorDash, used a very simple text similarity method as a guardrail, but text similarity didn't work all the time, so it just took all the hard cases, moved them to an LLM. So this is when we think about retrieval, it's not like a pick one or the other. You can kind of put these together as well. So I have a notebook here for kind of working with agentic RAG as well. I'm going to skip over this. We get this, like you guys get the trade-offs here as well, because I want to go to some of the other questions. So we had a bunch of these questions around chunking and contextual chunking and how we do that. So a big part and a big area for where you can improve your RAG is making sure you get quality information into your system and that you've used metadata, you've given it all the relevant information around it. So when you're bringing in your documents, for example, what I tell people is, as you're bringing it at the top here, add your metadata. You can already automatically have some processes that inject automatic metadata, what the data is, who the author is, some pieces like that. But if you manually have information inside your organization, like you need to work with those domain users and bring that in, then based on that, you're going to want to take that apart. Most of us are going to deal with complex documents that have like graphs, images. We want to be able to understand those. So using a vision language model, something that can take apart those. Generally, what I see the best is using image captioning. Ugh. No worries. There are like multimodal embeddings, but generally like you have to find a way to turn that image into some text. Because if you have, for example, a graph and it has, what the sales were in year 2020, years 2021, like you want that information in a numerical way. So having an image captioning model is very useful for that. Same thing with table extraction. It's a thing into itself to be able to extract from tables. Now, once you have all that information, one of the critical questions we have is, how do you create the chunks? Should you think like, hey, we have long context models, I can just pass really long chunks in? You could, but I don't recommend that. I mean, I'd like to remember at the end of the day, you're going to be retrieving these chunks and using semantic embedding models. So I'd like to keep chunks a little bit on the shorter side. So basically there's like one concept in there. So that way you can easily kind of find it. Now, with these reasoning models, they can understand different aspects of your chunk. So if you include, for example, metadata, like what section you're in, what chapter this is in, what book this is in, like that makes it easier for the models to understand what's going on when it's writing your generated piece. So I think everybody pretty much kind of widely agrees that like injecting some amount of data into your chunks is useful. Now, how much information, there's, I think, some judgments varies where some people put literally like the entire summary of the document in there, like some just do the headings. There's a bit of variation and it can really depend on your problem. But the idea is adding more of that contextual information makes it easier when it's writing the response because now it knows, hey, this chunk came from this particular chapter and it was in this subheading with 3 other subheadings. And so whether it's writing a response or whether you're using it in a retrieval where it says, oh, well, I'm going to go retrieve those other subsections too because I need that for a final answer like that. So I don't have like a gold answer. We, by default, like to use a document hierarchy approach, and we embed that into the chunks. We let people decide if they want that or not, but that's a good default that has worked really well. I think the other thing is it depends on the types of documents. If you have lots of emails, maybe just simply cutting them off at the tokens works really well. If you have slides, for example, like PowerPoints, you don't necessarily need to use a fancy hierarchical thing. You can just treat each page separately like that and make a chunk for each page. So you keep all those contents together like that. All right, what else on chunks? I know you guys had some questions like that. Does that cover a bit about that? Mm-hmm. Yeah. So it's tough because if you get a table that's small enough, right, you can put it inside one chunk. That's the easy problem. The hard problem is now the table has to go over 2 chunks. So how do you break that up, right? Where you want consistent headings, for example, among it. So a couple of the things that we use, for example, is we've favored using HTML as a way to represent the table, simply because it's a good way to keep the structure like that. But this is where you can inject and try to get those same headings there and then work on the generation side to make sure you pull it or that those headings come consistent, but it's a tough problem. And this is where like basically all the vendors like us like kind of have extra proprietary approaches for those tables because there's no easy ways to kind of do that when it gets to that. Yeah. So yeah, no, it's a tough problem. And I mean, maybe as we get to, I mean, like a variable context or something where maybe you just have a larger chunk that takes it all in, but still it's hard to process that and like all that and find that information. So we'll see. I mean, we'll see if like maybe the agentic approaches will help with like multiple calls, like give it up and just do multiple calls and try to stitch that together. But yeah, I don't have an easy answer. That's always a place where everybody struggles with is complex tables like that. Yeah. Yeah, I don't have a good answer for that. I don't know as well for the code-based. I mean, I would be thinking you would want something that would represent like how the code is structured like that, but I don't, I could, you'd be better off doing an internet search than having to answer that question like that. I haven't done a lot of RAG on code like that. I mean, but you see, right? Like what are the examples that I showed you? What are they doing? Right? They're just using like BM25. They're not even really going through that traditional RAG route for that. So I think you'll see a lot of code searching strategies that way. Mm-hmm. Yeah. So I think one of the big problems for people that are doing RAG, that are like starting in a company that has PDFs, is there's very few public benchmarks that actually start from PDFs. Most of the benchmarks are heavily focused on retrieval and just look at like how well I can find text. I published on Reddit. There's a RAG subreddit. Like there was a data set Vectura put out that started at PDFs and went all the way through. The problem was it was a really easy data set. Like I ran it through once and got like 92%, so it wasn't very, very challenging. The Open RAG benchmark or something like that. If you contact me, I can let you know. So starting from PDFs, there's not a lot of good benchmarks like that. Most of the stuff is heavily in the retrieval. The Wix QA starts from HTML or text. So it gives us a little bit closer to like a realistic kind of thing, while the Bright is just a corpus of lots of different text that's already been formatted like that. Like you don't have to go through any of the chunking process like that. And so this is where when we talk about what's the best chunking techniques to use and stuff, like there really isn't a ton of work in that area that's easily kind of reproducible in that way. So I think we talked a little bit about generation. I didn't spend a lot of time on like the generation side of RAG, simply because like we all know generation's important. We don't want a list of search results, but these models have improved the last few years, and it's pretty easy to kind of pick out what you need, right? Like with Contextual, we have a low hallucination one, but for the most part, people use GPT-5, Claude, whatever models like that based on their cost consideration like that. Sometimes maybe you use like a language-specific model like that. When it comes to these generation models, right, like just because they have a huge context window size, don't think you can get away with stuffing that context window size there, right? There's been other ones showing about how they lose information at different spots, or like context rot was another paper that came out a few weeks ago around kind of over-indexing on large index models like that. Oh, go ahead. Yeah. Yeah. I don't like I did a bunch of like code-based stuff like a couple years ago when I was at Hugging Face. Since then, like I've worked with enterprises, and largely like everybody just has lots of documents, and I have not I don't know as much about like code-based search and what would work in that piece like that. So, well, thank you all for coming. I appreciate it.